The third fallacy I showed you was this one, which had to do with this imaginary number business, okay? And I will admit, I was kind of taking a bit of advantage of the fact that you're not very familiar with how these numbers work, but still, it seems to function and convince most of you and have you very confused. So let me show you how it works. Most people, and by the way, I played a bit of a trick on you. It's a well-known principle in magic that if you want to trick people, what you do is you draw attention to something, you make a big deal about something, which has nothing to do with how the trick actually works, right? So people get distracted, they get convinced that that's what they need to concentrate on, that's what they need to watch carefully. You'll even hear magicians say, okay, now watch very carefully and that's an almost certain guarantee that the trick is either already finished, right? So you've missed it, or they're going to do that and then off on the side something's happening that you're not paying attention to, and that's where the trick really lies, okay? I did the same thing here. Most people thought, I made a big deal out of this part here, right? And people said, you know, a half equals 2/4, right? I established that. And because I made such a big deal about this, right? I had some people convinced, people were like, no, maybe a half really isn't 2/4 because this seems to lead to problems, obviously, okay? Or alternatively, some people thought that this was the issue, me breaking apart the indices, okay? But it's very easy to see why this is not a problem, right? If you go back to your index laws, right? If you have something raised to a power and you raise the whole thing to a power, okay? Our index laws tell us this, right? M, n, and that's really a to the power of m times n. But you can see if I reverse these, this is no issue, right? If I go put the n there and the m there, just interpreting this law the same way, this should be a to the power of nm, which is m times m. And look, multiplication, you can change its order. It's a commutative operation, okay? So therefore, these two things, they're equal. No problems, okay? So people again thought the issue was here, okay? They thought it had to be an issue because when I get rid of the negative, right, that seems to be where I get to show this very unconvincing result, okay? But I had you all fooled. Here's where the real problem is. The real problem is in the very last line, okay? Now I've included this one, which I didn't include in the original proof, just to show you it's not because I'm mucking around with the definition of an index or anything like that. That's not the problem, okay? It's easy to see that there's an issue here because the fourth root of 1, okay? If I give you an equation like this, right? X squared is equal to 1. Right? Everyone knows because we're familiar with quadratics that there are two solutions to this and they're plus or minus 1, okay? That's a quadratic. Degree of the polynomial is 2. By the same logic, it ought to be stand to reason that if it's a power of 4 equals 1, then there shouldn't be 2 solutions, there should be 4 solutions. And there are 4 solutions. The 4 solutions are plus or minus 1, just like here, right? Or plus or minus the square root of negative 1, okay? Because think about how this works, right? Let's go with the positive square root of negative 1, right? If I multiply this by itself 4 times, okay, I'm going to have the square root of negative 1, the square root of negative 1, the square root of negative 1, and 1 last time. And this is easy, right? These two will become negative 1. These two will become negative 1 as well, and then they'll cancel and you'll get 1, right? You can rehearse the same thing with the negative square root of negative 1 because you'll have 1, 2, 3, 4 negative signs that will all cancel. You'll still end up with a positive, okay? So in fact, the real issue is that this statement here, from that to that, they're actually equal. They are equal. But I chose the wrong solution. It was just like with the trig fallacy before. This is a valid solution to this, but it's not the right one in this context. I should have chosen this one, and that's where the fallacy lies, okay? So, clear misdirection. Watch out when people tell you, pay close attention to this because they're probably trying to trick you.